Hey y'all, CB here, the No BS Welder here at NBS Weld, and I'm fixing to do an updatification of the current situation. I'm pinned down at the shop today. I got steel being delivered. When you're a one-man operation, got steel being delivered, and you got to offload it. It means you can't go out and do field work that day. So that's one thing. I saw some tires, a set of Falcon ATs on Marketplace for sale used this morning. They were about half tread or so, and they're a 37 1250. That's bigger than I want, but I told the guy that I was pinned down at the shop today, but if he wanted to bring them by here between 10 a.m. and 2 p.m., I'd give him cash for them. We'll see if he takes my offer. The pictures of the tires that he took, he had them in the back of his truck. And it made me think, hey, I can't leave today because I got steel being delivered. But if they're in the back of his truck and he's in Buchanan like it said, you know, maybe he'd be willing to bring them by here. We'll see what happens with that. That might be a bad idea. I don't know. They're 37 1250s, and I was going to get 33s. But anywho, I'm going to see what happens there. The next thing is on the tractor. While I'm waiting, I got to do some stuff on the tractor, you know, with this idea of making a lifting device on it. And I'll show you what I've done so far. Obviously, I put the loader on. So we got the loader on the front. Still got the forks I built on the back. So if you've been following my shenanigans, you know that last thing I built for the tractor was this set of forks here. Another thing I did this morning, I put a Tough-Flex on the ROPS bar, and I cut me a little piece of chain that I can connect with those shackles. And see that your 3-point hitch, if I just run it clear down to here, it just floats. That means I could lift up weight and let that down if I wanted, you know, if I wanted to drop the mower down. Because if you probably seen, if you were watching me lift stuff with them forks in the video when I got done building them, you might have noticed that the mower deck goes up and down because that's how this tractor works. That lever raises the mower up and down in the 3-point at the same time, because normally you would not have the mower deck on there and something like a tiller. And when I put the tiller on there, you know, the mower deck, I take it off. But I can see how you might not always want to take this fork. You might want that fork thing on the back when you're leaving the mower deck on there. And there may be times even with the mower deck off there that you just want the forks to hang. You know, you don't want them to be held up by the hydraulics. And for that reason, I thought that little strap deal. I'm not going to make anything more complex than hanging a Tough-Flex on the ROPS bar and hooking the chain on it. You know, you could get more elaborate than that, but I don't think you need to. The big thing that's going on right now is I want to find out how much weight I can put on the back with the loader on the front. How much can I put on there and carry around without the front tires coming off the ground, you know, and making it so that you can't steer? Well, obviously, you know, you could take weights and put them on there, but what I've got right here is a water tank that belongs to my neighbor that I'm going to borrow. And the water tank is awesome. I got free well water, and I can start filling that thing up with water, and I'll just fill it up with well water till I see the front tires come off the ground. Then I can let water out of it until I'm happy with it. And knowing that water's about 8 pounds a gallon, I'd have a pretty good idea what kind of weight that I could have on those forks. And that, you know, we're going to learn something here. This is an easy way to do it. It's a whole lot less work and hassle to fill this tank up with water and let the water out of the tank than it would be to try and find actual pieces of weight, you know, and do a calculation that way. So that's what we're fixing to do. I'm going to start putting water in it. And we'll see when the front tires come off the ground. I'm happy with what I'm seeing on everything so far. And the big part of it is with the loader on here, the front tires are not off the ground. And this thing is completely full of water. That's good. Because if the front tires had come off the ground before that was full of water, I'd have thought, I can't pick up much. Having the loader on the front has really made a big difference on what I can do with the back. So take a look at what we got here. Going by the numbers on this tank, if this is 100 gallons and we're completely full, at 8 pounds a gallon for water, we got at least 880 pounds of water there. The tank and the pallet doesn't weigh much. Couple things we want to see now. Yeah, it's holding it, but will it lift it? That's number one. Number two is, how far out the forks can I run that amount of weight? I wouldn't think I could run it very far, because every inch that water goes back towards the end of those forks, that's really making it harder to pick up. So, and you just imagine, I mean, you look at the distance with the arms and the assembly, we're already quite a ways behind the tractor before we even get to the water. So, this is going to be cool. I'm going to see if I can drop it down, pick it up, and if it'll lift it, then I'm going to start driving the tractor forward and see how far forward I can lift that amount of water. Yeah. What I'm hoping that you can see from that video is when I put my arms up in the air, I had thrown that lever all the way back and let it go. And that tank of water just barely raised up. And, you know, the couple times before that where the water was right against the mast, it lifted it up no problem. But look where we're at now. So I'm, 6 inches or so back, and getting back on the forks like that, every inch you go that way is more labor for it, it's harder for it to lift. And so that thing completely full, I couldn't run it. I couldn't move that tank any further back on the forks and lift it. So, what's that tell us? It's like, I'm going to let water out of this. So one thing I kind of know is I don't have to have a weight that's that heavy, because I can always make it seem like it's weighing the tractor down more by moving it back farther. And I don't want to make a weight any heavier than what it needs to be to weight the tractor down, to the maximum potential. So, No problem, 520 pound of water. I can't get the 520 pound of water to fail to lift. I ran it all the way back on the forks as far as it would go, and it still lifts 520 pounds of water. So a 520 pound weight would not be enough weight. We don't need an 880 pound weight, but we need to be more than 520 pounds. I think we got enough information that we can take a guess. So here's what I'm thinking. Years ago, I built an aluminum transfer tank for Johnny Vaughn because this steel transfer tank that he had was leaking, and he didn't want the old leaking tank. So it's been sitting here for a few years. The good thing about a diesel tank that's been sitting here on its side with an open top for a few years is it's not even probably going to smell like fuel. I wouldn't be a bit concerned about cutting on this. All of the volatile compounds from the fuel in that tank are probably evaporated. But looking at this tank, thinking about needing a weight, this tank is 49 by 9 by 19, and if we were cutting the top off, let's say we cut 2 inches off the top, because we could use the top of the tank to make a couple fork pockets, and we would want them to be 1 inch or 2. See, if we were going to do fork pockets, I would say 1 inch. So we're 49 by 9 by 18. Let's do some math. Got my project calc. These are nice. They'll do fractions. We're not needing to do fractions now, but see, you can do 3/4 with that. Anyway, got my project calc. I got 49 times 9 times 18. 7,938 cubic inches. Now, converting cubic inches to gallon, you would multiply that by 0.0043. So we got 49 times 9 times 18 equals 7,938 times 0.0043 equals 34.1 gallons. 34.1334 gallons. Concrete's 20 pounds a gallon. So times 20. 682 pounds. If we cut the top off this tank, use some of the steel in the top of it to make a set of fork pockets, we'll make them the distance we want so that the forks, when they're spread out wide, will slide into those pockets and it won't come out. We have 682 pounds of concrete in there. We could even go a little less than that. This is the answer. Well, all right then. That settles it. We need to take that tank, cut the top off of it, use the top to make a set of forklift pockets, weld the forklift pockets through the tank, flip the thing upside down, fill it up with concrete, let the concrete cure, flip it back over, and we'll have us a weight for the tractor. All right then. We definitely got a plan for the weight. And I can definitely use that weight whether the rest of this idea works or not. But moving forward with this idea and doing a little further investigation, what we got to know is if I built a jib long enough to lift things up in the air with a wireless winch rig that I've already got made, would the tractor pick it up? You know, how's the tractor going to handle it? How much can it weigh? How long can it be? We got to do some testification, see? And that's what I got rigged up right here, so let's take a look. This rusty apparatus right here, made out of rectangular tubing, is something I built years ago, and it's been around here forever, and it's been used for a lot of stuff with the shyster. I know one thing I did with it, I welded this pipe on here, and I drive up to a fifth wheel trailer, and I'd lift that pipe up onto the fifth wheel pin, and I could use the forklift to drive the trailer around the lot. You got to put air to the brakes and release them, but it's no big deal. It can be done. And the other thing is, like lifting things where I had to reach out, I would use those forklift tubes to put it on the forklift, and I could hook a strap or I think I got a hole cut down in there somewhere where I can hook to it, and did different stuff, lifting stuff. And another thing I remember doing with that was lifting pipe with it. At one point when that little pipe wasn't welded on there, the big pieces of pipe, like 10-inch and 12-inch, I would just use that like a pole and slide it in the pipe and lift them, carry them around. But what we're doing with it right now, I've got, steel came today, so I got plenty of work to do. This pipe right here is 2.5-inch Schedule 40 pipe, comes 21 feet long. So these are two brand new 20-foot joints. I picked them up with the shyster, and then I drove that tractor over here with that pole rig on it, and I've strapped all this together to see, with these pipes here and that 21 foot sticking out there, if that Kubota would lift that up. I still got 520 pounds of water on the back of the Kubota, and we're just going to have to see. There's more weight here than probably what I need. The end of this thing doesn't need to be 2.5-inch pipe. That would be overkill. I wouldn't mind having 2.5-inch pipe down there at the base, but you know, this thing could get a little smaller as it went up, because we're not talking about lifting a hell of a lot of weight with it. Yeah, will the Kubota lift this thing? Will it handle it? If I build a rig like this, you know, could the tractor handle it? Because really, the main thing is having the tractor to lift it up and stand it up. Once you stand it up, you know, there's other stuff you could do. You could have a base for it that flips out and stabilizes it, where the tractor wouldn't really have to do nothing else. It's just got to carry it around and get it into place. Let's do a test on this and see what happens. All right, in the break room here, doing a little thinking. I approach all of this redneck engineering or whatever work I'm doing just like running a bead of weld. Man, you got to strike that arc. You got to fire that thing up. You got to get it going. You got to watch that puddle. If things are going good, then whatever you're doing, keep on doing it. If it's not going good, you might have to manipulate things a little bit. You might have to do something different. If you start doing something different and the situation looks better, keep doing what you're doing. If it looks worse, abort and change the plan and manipulate that puddle in another way. And do that so quickly that if you make a mistake, you fix that mistake when it's like this. You know, if you're making a little weld and you got a little problem and you fix it, ain't nobody gonna know. If you take off first thing not knowing about the exact rod or heat or wire or whatever, and you're on the maximum voltage, you're running her wide open, and you don't really know what you're doing yet, and you fire that thing up and you're making the biggest, hottest weld you can, and you have a problem, dude, you got a big problem. I mean, you ain't gonna just manipulate that a little bit and fix it. You're gonna have to go get a grinder. You might have to go get a torch, garden arc, fix that. So everything, when I'm doing something, I'm trying things, I'm watching what's happening. Is the situation getting better? Is this worth pursuing in the manner I'm pursuing it? If not, can I change? Can I make a move? Can I do whatever? Okay, I've had an idea about building a mast to lift things with that wireless winch that I could carry with the front of my tractor, and the tractor would somewhat be a static weight to hold it there. I'm not expecting the tractor hydraulics to hold up the load. But I've had this idea. Well, why is this idea so significant? One thing is I've got the tractor. Another thing is, a lot of people, I know the local contractors, my buddies that are contractors around here, if you tell them you're going to set this thing, I know what they're going to tell you. We'll get my telehandler and set it. Telehandler's right over there, or, whatever. Or I can trailer that telehandler out there and you can set it with that. Hell, that telehandler will set whatever you want. Yeah, we set a lot of stuff with a telehandler, and a telehandler is a great machine. Look, here's the thing. I'm a one-man operation. I run into situations where I want to set something in place. I don't want to bring some guy out there to run the telehandler while I'm up there goofing with the thing. My ideas that I have about work most generally have to do with figuring out how I'm going to do this by myself, because I like to work by myself. I don't want to be watching for somebody else's safety. I don't want to be worrying about what they're doing. When I'm doing something, I just want everybody to get out of my way. Now, obviously, there's a lot of things you need help to do, but the things that I do generally are things that I can do by myself. Now, if I had this mast and I can run this thing with a wireless winch, there's a lot of things that I can think of that I could set in place and work on and do by myself. Because I can, just like in the shop with my hillbilly bridge crane, I can be the guy that's not only there to do the tack or whatever, to do the work, but at the same time, I've got a wireless control in my hand that manipulates the load. So I don't need an operator and me if I got a rig like that. And another thing about this mast, I'm thinking, I need to measure the height of my building, but I think it would be a viable option to lift me. And that's two things. Like, if you build this mast in a way that the braces that go across it are a ladder, then I've built a ladder that I can climb. I can put on a harness. I can tie off, But I could get also a boatswain's chair and sit in that chair and latch it to that winch and lift myself. And see, like the tractor being such a viable off-road machine, four-wheel drive tractor with a diff lock, this is something I could drive in my yard and paint down the side of my building, sort of like a man lift. So there's a bunch of ideas coming up here that I'm liking. And what we saw in my last test was that I had two 21-foot joints of 2.5-inch Schedule 40 pipe, plus that rusty old forklift extender. And the thing that's coming out of that, I think that's a 6x4 by 3/8 wall, rectangular tube coming out there, maybe 12 feet. That amount of weight that I watched that tractor lift like that, that's enough to do something with. So that's the reason I'm talking about, the way I'm approaching this is I'm just saying, hey, here's the thing I can use to weight the back of the tractor. That makes it so the loader can handle more. Well, now how much can the loader handle? Well, the loader can handle plenty to make it worth me making something to hold my wireless winch up to lift with. If I can't lift enough weight with it to lift maybe a sign frame or set something in place, I bet it'll lift me. So if it'll lift me and I could just use it as a means to lift myself up and paint the side of my building, then it's a viable option. So I've started into an idea and I'm seeing what's working. And I'm doing some calculations here. And what I've done put 2 and 2 together, and I added 12 and carried the 1, and there was 12% of the factor of the rotary girder, and whatever. Look. Stay tuned for more doozing, because this shit's going to get interesting. Hey y'all, CB here at NBS Welding. We're in the break room doing a quick merch video. For any of you that are interested in merchandise to help support the channel, we got the stickers. Small size sticker, like a hard hat size, $3. Got the bull logo, NBS Welding, got the name and phone number. The medium size, $5. And then the big bumper sticker, $10. Now, there's no shipping on the stickers. We can put these in an envelope. It's pretty simple, no problem. Next thing is the shirts. We did have some trouble with the shirt order. We just got proof that they fixed the problem they had, and they sent us the proof. So they got it right where the NBS Welding logo's on the chest, then the great big NBS Welding on the back, with the American flag on the sleeve, the way we like it. $25 for an NBS Welding shirt. These will be here, supposed to be here September 5th, so we're taking orders. Got a couple orders already. Wayne and Mike, you guys, you're going to be getting your shirt. It's coming. Next thing I want to talk about the cup. My buddy tried to make these cups, and I wanted the QR code on the cup, and he couldn't figure out how to make it work. He made me cups. The QR code wouldn't scan. He said he didn't. He finally gave up. He wanted to give me my money back. I said, no, not all of it. We're going to share the responsibility. Anyway, he gave me a portion of my money back. I gave him enough money to cover what he spent, but I continued to work on it, and I got it worked out. I don't think my cups are as nice as his, but they work. And here's the thing. The QR code's got to be on the top where it's flat. If it's on the radius on the side of the cup, it's not going to scan. It's got to be on the top. I figured it out. But we got the cups. NBS welding with the bull logo. Got less yakking, more tacking. Pretty simple cup, but like I said, I made this myself. I bought the cups and the materials. I put it together. Had to make it work. I didn't want to quit on it. Now I want to talk about this real quick because this something come up. A way for that you can give to the channel is through Super Thanks, through YouTube. And our guy Corey has given $100 Super Thanks repeatedly. And I keep thinking like, man, this Corey has contributed so much. I really want to do something to thank him, and I couldn't think of what I could afford to do. And I remembered these coins. Now, I had these coins made when I was making good money working in the oil field. And what this is, this is 1 troy ounce of 0.999 fine silver. It says NBS Welding. It's got the name and phone number and the designation 0.999 fine silver. So this is an ounce of pure silver. And if you turn it over, it's got the bull logo on the back. This coin, I'm sending this to Corey to thank him for all the super thanks that he's given. There's one thing that is. There's 2 things about Super Thanks. It's super easy for you guys to contribute to a YouTube channel through Super Thanks because you can go on your device and you can hit Super Thanks and boom, it's quick. It's easy for you to do. The problem with Super Thanks is YouTube gets 30% of that money. So out of a $10 Super Thanks, you're giving YouTube $3. But it's kind of like that with the merch too. If a shirt's $25, we have to buy the shirt. So I have to put money in, there's money going somewhere. Anyway, this idea came up to give Corey a coin. And it's got a real nice little plastic case I'll show you. I just put it back in the case. That keeps them from getting fingerprints all over it. Here's the thing. When I got the idea that I was going to give Corey the coin, I wanted to offer it to everyone. So if you're interested in a coin, $50. Send Tina an email. nbswelding@aol.com. And thank y'all.